Yeah, good morning everyone. So we begin a diode. Diode means this die means two. This order came from electrode, something like that. Electrode. This is electrode. So it means two electrode, right? So actually it came from a vacuum tube. In a vacuum tube, uh, say vacuum tube is uh, this vacuum tube was used long time ago. Say so this vacuum tube has two electrode, three electrodes, four electrode, five electrode, or something like that. Okay. Say we can just five electrode vacuum tube. So say this is a vacuum tube. Many kinds of vacuum tube, right? Uh, in a two electrode vacuum tube, see this is diode is just a two electrode vacuum tube. Uh, say an electrode which is called cathode, uh, and there is a heater here, heater, and there is one electrode which is called anode. They are placed inside the vacuum. Okay? This is my vacuum. Vacuum. Vacuum is this is my vacuum. When heated up, electrons come to the surface of this cathode material. When temperature goes up, electron is emitted to the surface. If I apply, say, this cathode voltage is 0 volt. If I apply plus 100 volt at the anode, or maybe 300 volt here, those electrons on the surface of cathode will be attracted toward the anode. So there is a current flow. If there is a negative voltage applied at the anode, so electrons cannot reach this anode. Current doesn't flow. Yeah, that's a diode, vacuum tube. So diode flows current in one direction only. So, that's what diode does. Diode flows current in one direction only. Okay. That's a property of diode. We use the same name of this diode in a semiconductor. Okay. So when I have a P-type silicon here and N-type silicon there, this can be a diode. Okay. So I apply voltage here, then current can flow there. Okay. So the IV characteristic of this diode is IV. Yeah, you can see this is current doesn't flow. So current flows when V is positive, okay? When P-type silicon is positive, positive voltage applied at the P side with respect to N side, then current flows. Otherwise, current is zero. That's diode, okay? All right, homework number 2. Wow. So, yeah, just operation of PN junction diode. And then, say we need a transformer. Say the primary usage of diode is a rectifier. Rectifier is just convert AC voltage into DC voltage. This is AC voltage, right? So it uh, our power transmission system is based on AC. So we have to convert this AC voltage into DC voltage, right? So it just convert it like that, okay? Just a positive. So if I use some regulator, and this will become very flat DC, okay? So for the AC voltage, I have AC 110 RMS here. This is RMS. It means 110 square root 2 sine 2 pi 60 hertz. This voltage is supplied from the power station. Okay, I will reduce it into say something like a 10 volt amplitude. This is amplitude, right? RMS will be 10 square root 2, right? That's RMS voltage. Then I use some sort of diode, and then I will make some positive voltage here and negative voltage there, something like that. Okay. So yeah, some reading rectifier circuit, some okay. Yeah, ideal diode, precision rectifier using op-amp and diode. This is a regulator. Regulator does say there is something like this kind of voltage. Oh no, so there is a filtering here. This voltage is 0, and then something like that, and then I will make it very smooth here, very smooth there, right? So this is a diode actually. Diode can do some regulate. Yeah, this is some transient response. So we'll talk about some turn-off transient of diode. Clamping circuit. So in this circuit, say if this is a 0, this voltage support only positive voltage only. Okay. So if I apply something like this voltage there, this VO will be clamped at 0, and then this voltage will be something like that, minus 20 and 0. Okay, that's what clamp circuit does. Okay. Sometimes it's called DC restorer. Okay. So this is a clamping circuit. This is you can say this is a rectifier. And this will be minus 20 volt DC. This will. Okay. Yeah, some more transformer circuit, transformer equivalent circuit, and this is another application circuit, and then charge pump circuit. See, if I have, for example, 20 volt DC, say I will have around 60 volt DC here. So if I make more diode in series, I can just increase this voltage, maybe 10,000 volt. Yeah, this is another DC-DC converter. DC-DC converter there is a 10 volt DC, and then I have a 20 volt DC there. So if I use L switch and maybe some diode, so I can convert DC1 to DC2 very efficiently, because inductor does not dissipate the energy. Okay. Okay, some rectifier and clamp circuit. Yeah, see, this is a filter circuit. Concept. Oh yeah, this is added. This is added. I'm not sure you have this one in your printout already. No, then those are added. Okay. Okay, question. No? 어? 아, 그래요. 앞에 그 잊어버려도 돼요. 네. 다음 시간에.